This is the important session. This is about clinical trials and getting drugs into kids. And with that, I'm going to introduce you to... I just can't say enough nice things about her, so don't worry, I'm not going to. I know, but she's just so cool. If you don't know if you're a family and you don't know Dr. Pedori, just give her a hug today, even though it'll be a little awkward. Because she's just such a great human and a brilliant scientist and a great doctor. So, Dr. Pedori.
Thank you very much, Mike. Right. And thanks to all of you for sticking it out. I'm really, really so grateful to everyone for coming and participating during the formal sessions and during the informal sessions. So I suspect this is going to be the beginning of a much, much longer conversation. Our next session is a little bit different. We have two wonderful speakers, and then we're going to have all of you do breakout discussions and then come back and we'll have a little moderated discussion. We're going to start with Dr. Jackie French. Dr. French is known to many of us in the epilepsy world. She trained many of us in the epilepsy world and has had a long-standing focus on clinical trials and clinical trial methodology. In particular, she's led a lot of efforts for discussion with people like all of us, but also with the FDA about being maybe creative and flexible about trial design as we think about rare epilepsies and genetic epilepsies. So we're really delighted to have your time today, Jackie. It's been wonderful to see you through the day, and we look forward to your talk.
Thank you. Thank you so much. I've been really enjoying all the talks so far and learning a lot. Always time to learn. This is my disclosure slide. I work with a nonprofit called the Epilepsy Study Consortium, and what we do is we try and speed new therapies of all kinds, both for common epilepsies and rare epilepsies, to people who need them. And fortunately, what you can see from this slide is that there are lots and lots and lots of companies that are interested in developing new therapies for epilepsy, and we all should be very excited about it. So for those of you who are not familiar, this is the way that we do trials in epilepsy and mostly in epilepsy. It's not a wonderful way, but it's the way that the FDA requires us to do it at the moment, pretty much. We have some new concepts, which I don't have time to talk about today. But basically, you go through some period of time where you don't do anything. That's the baseline. And the children or the adults or whoever are on their standard anti-seizure medicines. And then there is a period of randomization right here, the time of randomization, and people are randomized to either receive a sugar pill or placebo on top of the medications that they're already taking, or one or two different doses of the new anti-seizure medicine or whatever therapy it is, whether it be a gene therapy or anything else. You observe them for some period of time to determine whatever outcome you're looking at, and then the trial is over, and either there's an open label extension or you taper off the medication if things are not going well. So this is our standard design, just to keep it in mind. So in 2022, there are more trials in pediatric rare diseases than in adults, even though Ingrid is happy about that. Even though the rare epilepsies may only comprise something like 20% of all the people with epilepsy, they now have the lion's share of the trials. These trials, very importantly, could either be anti-seizure medicines. And we'll talk about what an anti-seizure medicine is. An anti-seizure medicine could work on any type of seizure. It changes excitation inhibition in the brain, but it doesn't change the epilepsy, right? It just treats the symptom of the seizure, as opposed to what we all hope is coming and what we've been listening to all day, which is the hope of a disease-modifying medication such as a gene therapy or something else. And I don't have time to talk about all the issues, but I'm just going to focus on a few issues that you have to carefully consider when designing trials in either SYNGAP1 or other pediatric syndromes with developmental and epileptic encephalopathy. So the first is, how do you select the trial population? The second is, how do you weigh risk versus benefit? And the third is, how do you count seizures? And then I'll talk briefly about a few other things. So, population selection. Most therapies, as I said right now, although that's changing, in 2022, the therapies that are in the clinic now, the majority of them are anti-seizure medicines. So if you're treating the symptom of seizure as opposed to the underlying cause of the seizures, is there a reason to believe that this anti-seizure medicine would be able to treat seizures differently if they were caused by SYNGAP1 or they were caused by something else? So, in other words, going to Professor Sheffer is totally responsible for this slide. This is our new epilepsy classification. We classify epilepsy by seizure types, by epilepsy types, by epilepsy syndromes, and then we have comorbidities and causes. So are we going to be choosing our population because they all have the same seizure type? Would we choose them because they all have the same syndrome? Or would you choose them because they all have the same underlying cause? How do you decide who goes into your trial? So precision therapy is when you say, I know exactly who's going to respond to this drug, and all of you know that we don't have precision therapy, right? Everybody in this room who has a loved one with SYNGAP or anything else knows that you have to go through that therapeutic odyssey where you pick one drug, it doesn't work, and then you pick another drug, it doesn't work, and then occasionally there'll be somebody who's very lucky, right? So picking who we decide to go into these trials and decide the drug does or doesn't work is really important. So as I said, anti-seizure medicines work on basic mechanisms such as decreasing seizure spread or increasing inhibition. So let's say you say, does one of these anti-seizure medicines work in SYNGAP or Dravet or something else? So you take an animal model of SYNGAP or Dravet and you put the drug in, and it works, and you're going to say, okay, that's good, but it's an anti-seizure medicine, so of course it works. That animal has seizures, it's an anti-seizure medicine, it's probably going to work. There may be some reason to believe that it is effective for a specific syndrome, like we've found that high-dose phenytoin works on SCN8A mutation, or should be avoided, as we know that sodium channel blockers should be avoided in Dravet. But what often happens is that once you do these animal models, then the drug companies decide that they're going to take one of these orphan conditions and put the drug into that orphan condition. You can see many examples of that currently, such as fenfluramine and cannabidiol in Dravet syndrome, clobazam, rufinamide, cannabidiol, and fenfluramine now in Lennox-Gastaut syndrome. So then you get an answer saying this anti-seizure medicine works in this syndrome. Is that precision medicine? Well, unfortunately, these studies only tell you that the drug is more effective, if you remember back to my first slide, is more effective than nothing, than a sugar pill, right? But what it doesn't tell you is that that drug is more effective than any other drug that's on the market for that syndrome, because we're not doing comparative trials. Or even that that drug will be more effective for that syndrome than any other syndrome, right? So if I had an antidepressant and I said, I'm going to do a trial of my antidepressant in people with hazel eyes, and that's an orphan because there are very few people with, anybody in this room have hazel eyes? Oh, a couple people. Okay, so I'm going to try my anticonvulsant trial in people with hazel eyes, which is an orphan syndrome. And I find, lo and behold, it treats depression in people with hazel eyes, okay? Then I can go out and I can say, I have a drug that treats depression in people with hazel eyes. Of course, everybody with hazel eyes is going to want that drug, right? Because it's the only one that's been proven to be effective in people with depression and hazel eyes. But what does that have to do with the price of eggs? So really, these trials have not necessarily told us that these drugs are particularly effective in any particular syndrome. So what is the solution here? Well, you can do a basket trial, which I'm very much in favor of, where you take a number of different syndromes or seizure types or etiologies, and you try the drug in several of them. You still have to pick, can't do everything, but at least you can do a few of them. Now, you can do that open label to begin with and compare each syndrome to each other. You can do it placebo-controlled. You may not have to power it so that every single group has a p less than 0.05, that is statistically significant. So what is the advantage? You can use it when you are not yet sure of what the ideal population is going to be. You can enroll small populations, and maybe if it's an anti-seizure drug, you can demonstrate in one fell swoop, instead of doing one trial in Dravet and one trial in Lennox-Gastaut and one trial in TSC, you can put them all together. And then, if they all work, then maybe you can do a larger trial, or if only one works, you can then pursue that. Of course, you can get a false signal because you're working with small populations, but maybe it's better than what we do now. It also could tell you if the seizures are going to be worsened, potentially, in one small population. So has it been done? Yes. So Ovid Takeda did this with two trials, the ARCADE trial and the Electra trial. The ARCADE trial combined CDKL5 and DUP15, and the Electra trial combined Dravet and Lennox-Gastaut. The disadvantage is that unless there's a large effect size, the outcome is unlikely to be definitive in any specific group, and the FDA doesn't like this. So for example, if you did come out statistically significant for a group as a whole, they still would want you to do individual studies with each of those groups so far. So let me go on to risk-benefit ratio. Most anti-seizure medicines, as you know, have to be taken every day. They have chronic side effects, such as fatigue, cognitive disturbance, unsteadiness, GI upset, and we call those dose-related side effects, but they actually aren't. They're exposure-related. So if I gave 5 kids the same dose, they would each, if you measured their serum concentration levels, they would end up someplace different. But all we look at in a clinical trial, unfortunately, is what side effects occurred with a given dose. Now, the problem is that it is very hard from the results that we get from randomized controlled trials to figure out the individual benefit or risk that a given person is getting. So for example, you have 25% of people in a trial who do spectacularly well. Well, are those the same 25% of people who are having terrible side effects? We don't know, because we don't measure it that way. And as we just talked about, the risk could be different, particularly for comorbidities with underlying causes such as SYNGAP due to the already existing comorbidities. So clinical trials will report, and this is just data I pulled for cenobamate, one of the more recently approved trials. So this is the percent over time that had seizure freedom, which is kind of nice, with placebo and 3 doses. So you see that about 30%, amazingly enough, of these patients, this is focal epilepsy, by the end of the study were seizure-free. And then you see that a certain percent are dizzy at each dose, and 36% are sleepy, dizzy, fatigued, but is it the same 30%? Is it the same 30%? So is it like this, where you get some people, this is the serum concentration and this is the percent seizure reduction they're getting. Some people are having side effects all up and down here, but there's some very happy people up there who are neither having side effects and they're having really good seizure control. Awesome. Or is it like this, where in order to get good seizure control, everybody's got side effects. You know, there are drugs like that, and the problem is, since we don't look at it that way, they get released onto the market, and then when they go out into the real world, nobody wants to take them. And then the companies are sitting there scratching their heads going, why doesn't anybody want to take my drug? But they could probably know that in advance. And then, you know, the question is, where do the SYNGAP kids fit into that risk-benefit ratio? And what can be done? So maybe basket trials to make sure that you're looking at adverse effects in specific groups, but we really need to work on better methodology, which we don't have now, that look at efficacy and tolerability in the same person rather than separating them out. Now, a really hard one, seizure counting. So seizure counting is an issue with all seizure types. People with epilepsy or their families, first of all, might not be aware that a seizure is happening. It might happen at night. It might happen when they're alone. These things happen with all seizure types. But we have sort of designated a certain number of seizure types that we consider to be impossible to count accurately. And why might they be impossible to count? Because they occur in clusters, occur too fast, too many in a day to keep track of. They may be very subtle and difficult to distinguish from just inattentiveness or tics or other things. And by convention, I'm sorry to tell you, absence, typical and atypical, myoclonus, tonic without fall, atonic without fall, are all considered to be uncountable seizure types. So they may appear on EEG, you could count them that way, but there's no way that in 2022, that you can wear an EEG forever during a trial, right? You might have a period of time where you're wearing an EEG, but you can't wear it forever. So unfortunately, the seizures associated with SYNGAP1 tend to be the uncountable seizures. Eyelid myoclonia with absences, myoclonic seizures, atypical and typical absences, and atonic seizures. So that's a problem. If you want to do a specific trial in SYNGAP, how are you going to count these seizures? So what are the consequences of having all kinds of uncountable seizures in a trial? Well, in some trials, they try and get around this by saying, okay, some kids can have both countable types and uncountable types. So we'll just ignore the uncountable types and we'll count the countable types. So in Lennox-Gastaut, it doesn't matter if these kids are having atypical absences or other types of atonic or tonic where they don't fall. They're just counting the drop seizures. But counting only some and not others may give, as you can imagine, a false impression of the drug's potential benefit. So, and then, you need a certain number of countable seizures to enroll in a trial and have a statistically significant outcome. It's a problem in Lennox-Gastaut because any kid that doesn't have enough drop seizures, no matter how many seizures they're having, will not get into the trial and will not be evaluated. And this can have a profound effect on the results of the trial. So I love this example. There was only one trial of clobazam, which we know is an effective drug in Lennox-Gastaut. The outcome measure, as I said, was only drop attacks. So here you have the drop seizures, and you can see the percent seizure reduction during the trial. In placebo, it was 12%. It was a beautiful dose-response relationship, low dose, medium dose, high dose. The higher the dose, the more seizure reduction you get. However, they also did look at the non-countable seizures, and that's what they looked like. So strangely enough, the non-countable seizures that they tried to count, and there was just too much noise to count them, right? The placebo group actually had a 76% increase. The low-dose group had a 53% increase. And I'm not saying that that's actually what happened. We have no idea what happened because they were trying to count the uncountable. So this is a huge problem. If you don't have enough countable seizures within your syndrome, what are you going to do? So, are there ideal solutions right now? No, there are no ideal solutions. For some therapies, there may be an option, and I just wanted to, I mean, whatever we decide to do, it has to be clinically meaningful, right? So reduction in seizures, we kind of know that we hope that that's clinically meaningful. But if we go to something else, you know, some people for myoclonic seizures, for example, have counted seizure-free days. Well, if you only count seizure-free days, you can imagine you could have one myoclonic seizure on that day, and suddenly it's not a seizure-free day, whereas before you were having 100, and you would be a failure. So there's you know, obviously you're losing data that way. One thing that we were thinking of is seizure-free portions of days. So let's say, you know, if you do morning, afternoon, evening, and night, and the family just had to write down there were seizures, whatever seizure type it was, absence seizures or myoclonic seizures, or not, during those portions of days. So since I have all of you in the room, I just wanted a show of hands. If I showed you a trial outcome and said, you know, whatever, if it was 30 days, there would be 120 day portions, that it went from, let's say, out of those 120 day portions, maybe 70 of them at the beginning of the trial had seizures in them, and now only 20 of those portions of days had seizures in them with treatment. Would that be meaningful to you? Raise your hand if you think it would be. Some higher, a little higher, need to see. Okay, all right, so that's not bad. So we can think about that, but obviously we need to work with people who, you know, live the experience to understand what a reasonable outcome measure would be. Technology, hopefully, will play a role in the future on seizure counting, but unfortunately right now it's not ready for prime time. Moving on, I've been talking about anti-seizure therapy mostly, although seizure counting is for both. Let's talk about disease-modifying treatment that work on underlying processes that cause disease or syndromes, or maybe a common mechanism, even neuroinflammation or programmed cell death or whatever. While some of these therapies may work instantly, and you have to think about epilepsy surgery is a kind of disease-modifying therapy, and it works instantly, so that's certainly possible. But many of these take time to work. They take time to work on the brain to have their maximal effect. So the real issue with disease-modifying therapies is when do you start looking at the outcome and when do you stop looking at the outcome. So most anti-seizure medicines you can expect to work within days of initiation. But if you have a slow onset of effect, it could be even you have to wait weeks or months. And then when's the maximum effect? Is the maximum effect now, or is it a month from now or 3 months from now? And you can only keep people in a placebo-controlled trial for so long. The Timecourse may not be, you know, like talk to the developers and innovators in the room. The Timecourse may not be known until the development has been, the therapy has been in development for years. But you have to design the trials now. You can't wait. So just as an example, we had an anti-inflammatory drug once upon a time. I'm not going to go into too much detail. It was an IL-1B inhibitor in animal models. You could see that this is a matter of days, but this is before the treatment was started. The treatment is started right here, and you actually could get a hint right there that the effect in rats didn't start right away. It took a few days, and then the seizures started to come down, and then the drug was withdrawn, and it didn't like come back immediately. It took a few days to come back. But when the company did the study, they did it in a traditional way, where they did the baseline, as I told you before, and they were expecting, you know, seizures are at a certain rate during baseline. Then when the treatment gets started, the seizures will go down, and therefore they're going to compare this period to this period, which is what traditionally you would do with an anti-seizure medicine. Turns out that when you compared this period to this period, they didn't see any difference at all. However, if, in fact, this is what happened, and the treatment did not work right away, but like it took a couple weeks to work, and then the seizures went down, and it lasted a little bit after the drug was removed, then you would want to look at this period here rather than this period here. And when you actually looked at that period, which we called the hybrid period, then actually you saw a very substantial difference between drug and placebo. But because that wasn't the way the original study was written for the trial to be analyzed, the drug was dead and it never went anywhere. So we don't want that to happen. So you need to make the best guess based on animal models of when the onset is going to be and when the maximum impact is going to be. But the other problem is that that impact may be different, as you all might imagine, for seizures versus the comorbidities such as cognitive disturbance and behavioral effects. And sometimes those effects may take months or even years to work. And again, you cannot keep people in a placebo-controlled trial for months to years. So recently we had a discussion about this. Dr. Pridori was there at the research roundtable that the Epilepsy Foundation runs, and we thought about doing a trial where you look at seizures for a short period of time, and then you actually keep people placebo-controlled, but you allow them to go ahead and add or subtract therapies after that and get along with, because you can't like just sit there and watch people having seizures forever without trying to do something about it, but keep that placebo control longer so you can look at the behavioral outcomes after that. And then finally, everything else. Recruitment, always difficult. Placebo exposure, we already talked about it a little bit, should be as short as possible. Comorbidity modification. There are no good scales, and we heard a little bit about scales today. That was fantastic, but there really are no good scales for most things that are appropriate, and certainly for cognition, for the many ages that you're going to be studying, the many levels of cognitive delay that you're going to be studying, so people are starting at all different places. These are usually long-term outcomes, as I mentioned, and unlikely to be assessed in a placebo-controlled fashion. And then the question about what to do, and we actually saw this from the citizen data earlier, where you're trying to figure out what your outcomes are. And let's say you decide that your outcome is going to be behavior, but only 40% of the children have a behavior problem, and 40% have a sleep problem, and 40% have a different problem. You're going to dilute your ability to see a statistically significant difference because everybody's got a different problem. So even if, in general, people are better, what do you do about that? So Emil Kakas, wonderful guy, created this multi-domain responder index where you choose 4 to 6 important clinical domains for that particular gene. You enroll all comers with all these different things wrong, and you score the patients on each domain, but importantly, if they don't have that problem, they can't get better or worse, but they score it equivalently for each of the domains. I'm getting better or I'm getting worse. And then, in the interest of time, I'm just going to show you this. Red is better on all the different domains. This is different patients on all the different domains. This was for a liver abnormality. And you can see that people were rating better, and this is placebo, and this is the drug, the active drug, and you can see that on all the different domains, there were more people getting better, but you couldn't have seen that looking at any one domain. Doesn't this seem like an awesomely good idea? The FDA hates it. They do not allow it. We have to work on them, but we will. And that's it. Any questions? I don't know if there's even time for questions. So.
We started. Sorry, we started today hearing about N of 1 trials. So, are there acceptable N of 1 trial strategies that incorporate placebo that should be thought about with ultra rare disorders where it's unlikely you're going to get a large group together to do a placebo-controlled group trial? Sorry.
Theoretically, yes, but the problem is when you're talking about an anti-seizure medicine, as opposed to a disease-modifying medicine, you're talking about, usually in order to get the power that you need, putting them on the medication, seeing an effect, then crossing them over to placebo, seeing the effect, and then maybe putting them back on the medication again. It is very onerous. So you can do multiple N of 1s, and sometimes that can be powerful enough to drive, an outcome. But you would need a drug that was very efficacious, because unfortunately, with our anti-seizure medicines, only maybe 1 out of 3 people responds. So you'd need to do several N of 1s. And the reason N of 1 kind of works in the gene therapy world is that you're looking for really, really big wins in a disease where otherwise the course is grim and very well charted.
And just sort of a corollary, what does the FDA think about that sort of N of 1 crossover design, which I know has been used for oncology? But
yeah. I mean, they understand the problems with small populations. The thing that they do not like at all is something that is not controlled. So I don't care how small your population is, they would say use placebo control, because people can talk themselves into a lot in regards to, oh, I'm sure this is making me better.
Lovely talk, thank you. I love the baskets, and one of the problems that I'm worried about with the FDA is around the DEEs, because they think it's all Lennox-Gastaut and Dravet, and there are a huge number more of DEEs. Is there a way we can get them to think about that and then say do a SYNGAP basket and a whatever gene basket? Because I think that's going to be critical, and at the moment Syngapians in Australia are missing out on CBD because they don't have Dravet and they don't have LGS.
That's
and
exactly
it's very
right.
frustrating.
So one of the consequences of that, by the way, is that suddenly the diagnosis of LGS and Dravet has exploded, right? Right, and we have been pushing on the FDA. I was saying to somebody else earlier that I have a cartoon on my door that says, Mrs. Smith, we don't have a cure for your disease. We don't even have a race for a cure. And, this is, we don't have a cure. We don't even have a trial for a cure. And, we know that there are so many non-syndromic kids out there who need therapy, and they're going to use these drugs, and there's no reason to believe, as I said before with the hazel eyes, there's no reason to believe that they're not going to work, right? One of the most tragic things I ever heard was from, someone who came to our research roundtable, a mother of a patient in the UK, in fact, and said, the Lennox-Gastaut trial was done for children with drop seizures. My kid has drop seizures but doesn't have Lennox-Gastaut, can't get cannabidiol. That kid down the road has Lennox-Gastaut and doesn't have drop seizures and can get cannabidiol. Doesn't make any sense. And so we are trying. We have had multiple research roundtables where, we're kind of holding them by the collar and trying to get them to see, but sometimes it takes multiple repetitions.
I had a question over here.
Yeah.
Thank you for your talk. something I noticed you mentioned a couple times throughout were designs that FDA liked or FDA didn't like, and that wisdom is a little bit opaque for many of us in the room. And it had me thinking, do you have recommendations for ways that an organization like SRF or a group of organizations can come together to drive some of those conversations with FDA to increase acceptance or increase their flexibility over time?
Absolutely. They have listening sessions, and whether they actually respond to the listening sessions, I don't know, but they do have listening sessions. Again, we have, I mentioned it a couple times, but didn't really explain, the Epilepsy Foundation, along with the Epilepsy Leadership Council, the CURE, and NINDS, and other people have a meeting with the FDA every year called the Research Roundtable for Epilepsy, where we pick one topic like this. So the topic 2 years ago was seizure syndrome or etiology, and we get 2 days in front of the people that make these decisions to sort of make our case and talk it out with them. And in a number of cases, we have actually moved them to change their idea about things. Other times, not so much, but then we come back, it's really funny, we come back and call it a different thing and try again, and then after about 3 times, sometimes we get there. So never give up, never surrender. But there are listening sessions.
Just first, Dr. French, thanks for your leadership and thanks for being here. It's important to us. A very SYNGAP-specific question. Our kids have tons of silent seizures, lots of absent seizures, and we have some literature that says they have more seizures at night. So even if you get over that, even if you pretend you can count absent seizures, which you can't, or that you can catch eyelid myoclonia, which is hard because our kids hide them, you cannot catch the night seizures. So this whole notion of seizure diaries and counting to me feels very 20th century, and we're 22 years into the next century. So my question is, it's two parts. One, when will we see hardware and software that allows us to count in a reasonable time frame seizure activity in the brain, which again feels like technology we should have? And how hard is it, recognizing that the costs are astronomical in trials for the good companies that are working on these therapies, to try to count multiple things and see what, similar to the Emil Kakis approach, right? Like, it's tempting to say to Stoke and others, well, you guys should just count everything in a trial. You should do MRIs and EEGs and blah, blah, but then the cost just gets insane, and that's a reality for them. So how are we going to get past this, what I consider to be a 20th, if not 19th century notion of counting visible seizures, and get to using technologies in trials so that we can really appreciate these precision therapies that are not only improving seizures, but are improving the whole brain?
By the way, we had another research roundtable on seizure counting because it's a huge issue. Bob Fisher, who's not in this room but should be, once said, seizure diaries are the worst possible way of counting seizures, ... except for everything else. And that was said about democracy once upon a time. The problem is if you go, so for example, I don't want to take up too much time here, but because of this, we can't count seizures anyway but by EEG, infant trials were mandated by the FDA to be by EEG counting only. And they recently analyzed data from that and realized that people couldn't count the seizures on EEG either. It was a hot mess, like 5 people looking at the same EEG counted completely differently. There was no operationalization of reading that EEG. Sometimes it's hard to say, that an EEG is showing a seizure or not showing a seizure, and there are some drugs that clean up the EEG but don't clean up the kid. So there's all kinds of things you have to think about before you go like charging out and saying EEG is better than clinical. But we have to very slowly and carefully and intelligently look at our different methodologies. For example, I'm excited about a company called EYES. Anybody heard of them? That puts on a pair of glasses, or it doesn't have to be glasses, but can be glasses, and looks at eye movements to count seizures. So there's lots of different ways to approach it, and we just have to make sure, and another great quote from James Cameron, often attributed to Albert Einstein, but he didn't say it, is everything that counts isn't countable, and everything that's countable doesn't necessarily count.
With that wisdom, I know there's one more question. Can it be a really brief question?
It's going to be very short. What about the use of expanded access, aka compassionate use, in order to allow some of these drugs to be utilized and for us to collect real-world data and evidence to prove or disprove the use in specific situations?
Real-world data, that's an anathema to ultimate drug approval. But as far as compassionate use, I should probably ask Stoke or somebody else to talk about it. No, they don't even want to talk about it. It's very, very problem-laden to even distribute drug for compassionate use, because God forbid things don't go right, they go wrong. Then suddenly you have an adverse event or even a death that you don't know is related to your drug or not, and that could kill your drug very early on. I mean, drugs in development are like small, delicate infants, and they have to be, protected very carefully so that they can grow into what we want them to be.
Thank you so much. We'll have more time for discussion after.